Hi, welcome back to my channel pibyme Maths. This is by WST01. Here we are solving October 2024 Statistics 1 paper. In the previous two parts of this video, part 1 and part 2, we have covered question number 1 to 6. So let's look at question number 7. Box contains only red counters and black counters. There are n red counters, n plus 1 black counters. Okay, there are n red, n plus 1 black. Two counters are selected at random, one at a time without replacement. This word is very important. Without replacement means if you are taking out one counter, you are not going to put it back into the bag. So the total count will be down by 1 when you go for the second selection. So here the total is, when you add them, you will get 2n plus 1. Complete the tree diagram for this information. We have a tree diagram here. There are n red counters and total counters are 2n plus 1. n plus 1 black counters total is 2n plus 1. Now when you go for the second selection, the total will be down by 1. Right? Okay. You have selected one red counter already. So now the count of red counter will be, total number of red counters will be n minus 1. The black stays the same. Always remember, when you add them, you should get 1. Here, the red stays the same. The black, it was, red was n before. It stays the same. Because the first counter taken was black, so it will be down by 1. So when you add both, you will get 2n by 2n is 1. That's all. It's a 3-mark question. Part B now. Show that the probability that the two counters selected are different colors is this. Probability of two different colors. It can be the first one first one red, second one black, or first black, second red, right? We need to take the probability from the tree diagram. So red, black, you need to times it. N by 2n plus 1, n over 2n plus 1 times n plus 1 over 2n plus. And then black and red, n plus 1 by 2n plus 1, n over 2n, n plus 1 over 2n plus 1 times n over 2n. If you look at it, it's the same thing actually. n plus 1 here, 2n plus 1, 2n here, right? So you can write it as, when you combine it, you can write it as 2 times n plus 1 over 2n times 2n plus 1, and you cancel 2 and n, you got the answer already. N plus 1 over 2n plus 1. That's all. That's part B. Part C now. The probability that the two counters selected are different colors is this. Okay, actually we have calculated it as n plus 1 over 2n plus 1. Now they are saying it is same as 25 over 49. Find the total number of counters in the box before any counter selected. So you need to find n actually. Cross multiply. 49n plus 49 is 2 times 25, 50n plus 25. Bring the 49 here, 25 here, you will get n is 49 minus 25, 24. So the total number of counters is 2n plus 1, which is 2 times 24 plus. They did not specifically say the total number of red counter or black counter. They say total number of counters in the box. So it was 2n plus 1, right? So 2 times this, 48 plus 1, 49 counters. Given that the two counters selected are different colors, that's a conditional probability. Different colors, that's a condition. Find the probability that the first counter is black. We need to find the first probability that the first counter is black. So apply the formula for conditional probability. P of A given B is P of A, first one black intersection two different colors divided by P of two different colors. The probability of two different colors is given here. It's 25 over 49, right? So the denominator is 25 over 49. The numerator, you can take it from the tree diagram. The first one black and two different color. The first one should be black and then two different colors. So black and red. N plus 1 over 2n plus 1. N plus 1 over 2n plus 1 times n over 2n. N over 2n, you cancel n and n, it's 1 over 2. We know n is equal to, we calculated here n is equal to 24. Sub in there. So you will get 25 over 49 times 1 over 2 divided by 25 over 49. 25 over 49 can be cancelled. You will get 1 over 2. That's the final answer. Question number 8. An orchard produces apples. The weights 8 grams of its apples are normally distributed with mean mu, standard deviation sigma. It is known that P of A is less than 162 is this, 162 to 75 is this. Find mu and sigma. We are basically going to frame two equations. So here we can take A follows normal distribution of mu comma sigma square. So the first one, P of A is less than 162 is equal to 0.1. Standardize the normal distribution. Z is less than x minus mu over sigma is 0.1. Use this coding, x minus mu over sigma, to standardize the normal distribution. Okay. They are talking about the area on the left hand side in the bell curve. If you look at the bell curve, Z is less than means we know the total area is 1, or this area is 0.5, this area is 0.5. They are talking about area on the left hand side of a point and the area is smaller than 0.5. So definitely the point should be here in order for this area to be less than 0.5. So what I'm trying to say, it's a negative number. Right? So if you change it to positive number by multiplying by negative minus 1, this area will be same as this area. So I can write it as Z is greater than, because area on the right hand side, when you multiply by minus 1, mu minus A over sigma is 0.1. Now we know this is a positive number, this is a neat value, so we can use the table actually. So in the table, the value corresponding to 0.1 is 1.2816. 1.2816 is mu minus A over sigma. Sorry, the A is 162, right? You need to put 162 here, 162, this value. So bring the sigma here and bring it here, frame my equation. You will get mu minus 1.2816 sigma is equal to 162. Take it as equation 1. Now using this, we are going to frame the second equation and then solve the simultaneous equation. Now let's frame the second equation. You can write this as P of A is less than 175 minus P of, you can split it this way, right? You should have learned the normal distribution to understand this. 0.7508. We know this value is 0.1. So 0.1 goes to the other side. You will get 0.8508. P of A is that this one, standardize it. Z is less than 175 minus mu over sigma. In this case, definitely this number is positive because the area on the left hand side is more than 0.5, right? So in the bigger table, look for 8508. The corresponding value is 1.04. So So you can write 175 minus mu over sigma is 1.04. Bring the sigma here, mu here, you'll get the second equation. Mu plus 1.04 sigma is 175. That's equation 2. And then it's up to you how you want to solve the simultaneous equation. You have two equations. Solve the simultaneous equations, but always use your calculator to get the answer. The first equation is 1.04, 175. And then the second equation, you can put any equations in any order, doesn't matter. 1 minus 1.2816 and then 162. You get the mu as this, so you can write it here. Mu is 169.176 ... Sigma is 5.5995, etc. Can round it to three significant figures. So mu is 169, sigma is 5.6. That's the final answer. It's a 5-mark question. Okay, let's look at part B now. A second orchard also produces apples. The weight B grams of its apples have distribution mu is 215, sigma is 10. So if you draw a bell curve, the curve is symmetrical about the mu, so this is 215. An outlier is a value that is bigger than this or smaller than this. Usually for outliers, this is the formula they give, right? An apple is selected at random from the second orchard. The upper quartile is given. Find the probability that the apple is an outlier. You need to find Q1 first. Okay, you see, Q3 is given as 221.74, right? So whatever difference you have here, you apply the same difference here, you will get Q1. So what I'm gonna do, 221.74 minus 215. I got this. So subtract this from 215. 208.26. That's a lower quartile. 208.26. So instead of just showing the diagram, you can write Q1 is 215 minus the difference between Q3 and median. So 221 minus 0.74 minus 215, you will get 208.26. Now IQR is Q3 minus Q1. This is Q1 minus Q3, 221.74. You get 13.48. Sub in here and then find the range of these values. So first Q3, which is 221.74 plus 1.5 times Q3 minus Q1 is what we just calculated, 13.48. And then Q1, 208.26 minus 1.5 times 13.48. Let's find this range. 221.74. 221. First, let me find 1.5 times 13.48. And I'm gonna store the value as A. Okay. Now Q3 plus this value. Q3 is 221.74. 221.74 plus, you have stored the value as A. You get 241.96. Okay, Q1 minus this value. Q1 is 208.26. 208.26 minus, I have stored the value as A. I got 188.04. So this is the range. So if a value lies between this range, it's not an outlier. So 188.04 is less than B is less than 241.96 is the probability that the apple is not an outlier. But the question says the probability that this apple is an outlier. So find this probability, subtract from 1 to find the complement. That's the answer. Okay. So how do we find this probability? You find the probability of P of B is less than 241.96 minus P of B is less than 118.04. We need to standardize this and find the values. Okay, first standardize this. P of Z is less than 241.96 minus mu over sigma is 10. Minus P of Z is less than 188.04 minus 215 divided by sigma. So I'm going to calculate these values first. 241.96 minus 215 over sigma is 2.696. Z is less than 2.696. P of minus P of Z is less than. Now I'm gonna use 188.04. Okay, minus 2.696. If I draw a bell curve, this is 0 for standard normal distribution. You have minus 2.696. We need to find the area of this, and then you need to subtract it from 2.696. This left hand side area, you need to subtract this actually. Okay, so this area is same as the area on the right hand side of the positive number, right? So we can do one thing here in the previous step, right? We will write, we don't split it, we will just keep it together. That would be better. P of this is less than Z is less than this. P of this is less than B is less than this. Okay, so you will get negative to positive in this case. You're gonna get so if you don't split it, it's going to be P of minus 2.696 is less than Z is less than 2.696. I don't know, the values are same. So we just need to find the area between them. It's same as finding 2 times area from 0 to 2.696. Instead of finding this area, we just find this area 0 to this and multiply by 2, right? How do we find this area? We find the area on the left hand side of 2.696, which is, take it as 70, minus this area 0.5, right? You should have learned the normal distribution to understand this. So I'm going to use the table value now. Okay, the value is 9965. So it's going to be 2 times 0.9965 minus 0.5. So 0.9965 minus 0.5 times 2. 0.993. That's the probability that the apple is an outlier. But the question says, sorry, apple is not an outlier. If the value lies within this range, it's not an outlier, right? But the question says, find the probability that the apple is an outlier. So you have to subtract the probability from 1. Therefore, the probability that the apple is an outlier is 1 minus 0.993. Why 1 minus? Because we are finding complement of this probability, you get 0.007. That's the answer.